Hello friends, in this video we are going to discuss about inverse Laplace transformation of integrals. So today we are going to discuss about inverse Laplace transformation of integrals, and also we're going to discuss another method, that is by partial fraction. Partial fraction method. Okay, so we're going to learn how to find inverse Laplace transformation by integrals and partial fraction method. Okay, so and this is my Insta ID. If you want to follow me then on Insta, then you can follow me, Lakhyajit 123. And before we start, please subscribe to the channel. This is lecture number 17 and previous lectures are in the description box. Okay, link of the previous lectures are in the description box. And please subscribe the channel if you are new to my channel. Also hit the thumbs up button and don't forget to hit the bell icon. Right, so now let's start. So inverse Laplace transformation of integrals. Now you see, if the inverse Laplace transformation of capital F of s is f of t, if inverse Laplace transformation of f of s is small f of t, then inverse Laplace transformation of integral of s to infinity, integration from s to infinity of capital F of s ds is given by f of t by small t, f of t by small t. Since f of t is this inverse Laplace transformation of capital F of s, because here you say this small f of t is the inverse Laplace transformation of capital F of s, so we can replace this small f of t by this, right? So hope you understood this. So that's why we can write just wait, we can write 1 by t into inverse Laplace transformation of capital F of s, and which implies inverse Laplace transformation of capital F of s is equal to t into inverse Laplace transformation of integration from s to infinity of capital F of s, right, ds. So this is inverse Laplace transformation of integrals. Let us apply this method in order to find inverse Laplace transformation. Let me give you an example from mathematical physics Lakhyajit's book, mathematical physics books by Lakhyajit. Okay, so let me show you one question. So suppose we need to obtain the inverse Laplace transformation of this is the capital F of s. Then let me show you the solution. So here capital F of s is 2s by s square plus 1 whole square, right? So how to obtain the inverse Laplace transformation of this, right? So inverse Laplace transformation of capital F of s, so we have already learned that that is t into inverse Laplace transformation of integration from s to infinity of f of s ds. We can use this method. So first let us integrate that let us find the integration from s to infinity of capital F of s ds, right? So integration from s to infinity capital F of s is nothing but 2s by s square plus 1 whole square ds, right? So if you consider that s square plus 1 is equal to t, then if you differentiate with respect to s, then it's going to be twice s is equal to t by ds, dt by ds, and that means dt is equal to your 2s ds. So if you substitute here, then what you're going to have, then you're going to have integration s to infinity of f of s ds, that's going to be equal to integration s to infinity. So you're going to have here 1 by, you have considered s square plus 1 as t, so you have s square plus 1 whole square, so it's going to be 2 square then dt. So 2s ds is dt, right? Here we have got, so that's what we have done, right? So hope you have understood. So 1 by t square means you can say integration of t to the power minus 2 is going to be equal to t to the power minus 2 plus 1 by minus 2 plus 1, and that's equal to what? That is equal to right, t to the power minus 1 by minus 1, that's going to be minus 1 by t. So it's going to be minus 1 by t, and t is nothing but what? T is nothing but s square plus 1, right? So this is the integration we have got. So you see we are integrating it from s to infinity, right? S to infinity. Okay, so now we are integrating it from s to infinity. Just wait. So we are integrating it from s to infinity. So the upper limit is infinity, lower limit is s. Okay, so that's why we can write, so inverse Laplace transformation of, here you can see we have got the integration of this is this one, right? So let's use this. So that is minus 1 by s square plus 1, and we are integrating it from s to infinity, right? So let's put the upper and lower limits. T is t into inverse Laplace transformation. If you put here infinity, that's going to be infinity. If the denominator is infinity, that's going to be 0, right? So that's going to be 0, then minus. Now let's put the lower limit, minus 1 by s square plus 1. That's what we're going to have, right? So then this minus minus, that's going to be plus, so we can write directly this way. So we're going to get this result directly, right? That's what we're going to have. So hope you have understood this. Now you see integration of inverse Laplace transformation of 1 by, right? Instead of 1 by, it will be better if I write a by s square plus a square, then that is equal to sine at, right? Sine at, and here the value of a is 1 here, so that's going to be sine 1 into 2, that means sine t, right? So this is what we have got. So this is the inverse Laplace transformation of capital F of s, and capital F of s is this, that is 2s by s square plus 1 whole square. So that's how we can obtain using this pattern. Now let's learn partial fraction method. Okay, so because this method is not suitable for all kind of problems, so let's start. So let's take another question that we're going to solve by partial fraction. Now let us solve this question. Obtain the inverse Laplace transformation of this. We're going to use the partial fraction method here. So let me show you how to do that. So here capital F of s is s plus 2 s square minus 4s plus 30, right? So now what we can do here, s plus 2, so s square minus 4s plus 13 can be written as 4 plus 9, right? So what we can do here now, so here you can say this is s square minus 2 into s into 2 plus 2 square, right? This part I'm talking about, this part. So this is going to be my s minus 2 whole square, s minus 2 whole square, right? So let's do one thing. Let me make it s minus 2 plus 4, right? Let me make it way. And here you see, so here we can write s minus 2 whole square and plus this 9 can be written as 3 square, right? So now let me clean this part. Okay, so now here you see this is going to be equal to s minus 2 divided by s minus 2 whole square plus 3 square, then plus 4 by s minus 2 whole square plus 3 square. Now here you see, as we have 3 square here, so we're going to make it 3. So how to make the 3? So we can write s minus 2 by s minus 2 whole square, just wait, s minus 2 whole square plus 3 square, then plus, so here what we can do, we can multiply 3 here and here as well, right? So then we can take 4 by 3 outside, let me write here 4 by 3 into, then here we're gonna have 3 by s plus minus 2 whole square plus 3 square, right? Plus 3 square. Okay, so now let me clean these things, just wait. So why I have done this, you're gonna understand now. Let me I will explain it now, just wait, just let me write it properly. Yeah, we have 4s minus 2 whole square. Okay, so now let us take the inverse Laplace transformation of capital F of s, right? So we have to take inverse Laplace transformation of this part, s minus 2 by s minus 2 whole square plus 3 square, right? And then so this part is taken out, then inverse Laplace transformation of 3 by s minus 2 whole square plus 3 square, right? So now you see what we're going to apply here. Now first compare with this s by s square plus 3 square, assume it this way. So its inverse Laplace transformation is cos 3t, right? Cos 3t. Okay, so if you take this one as f of s, then s minus 2 by s minus 2 whole square plus 3 square to be considered as 5 f of s minus 2, right? We're going to consider this f of s minus 2. Then if that is the case, then we're going to use this rule that Laplace transformation of inverse Laplace transformation of f of s minus a, that is equal to e to the power at f of t. F of t means inverse Laplace transformation of f of s, right? We're going to use that. Okay, so if that is the case, so inverse Laplace transformation of this will be here you see f of t is this one here, that means inverse Laplace transformation of f of s is this cos 3t. So in this case this is going to be equal to this thing is going to be equal to, if you apply this rule, then e to the power, that's going to be here you see 2t cos 3t, right? So hope you have understood this. Now let me clean these things. So what we're going to use here in order to simplify this, let me write here, if inverse Laplace transformation of f of s, just wait, if inverse Laplace transformation of f of s is or just wait, you can write you can remember this directly. If here you see inverse Laplace transformation of capital F of s minus a, that is equal to e to the power at inverse Laplace transformation of f of s, right? F of s. Okay, so let me write it properly. capital F of S, right? So now compare this one with this one and this one, right? So here inverse Laplace transformation of f of s minus 1 is this one, right? So what gonna be then f of s? F of s gonna be equal to inverse Laplace transformation of f of s in this case. So ignore the 2 s minus s square plus 3 square, that is the f of s, and that is equal to cos 3t. So now what is the value of a here? If you compare s minus a with s minus 2, then value of a is 2. That's why inverse Laplace transformation of f of s minus a, in this case it is inverse Laplace transformation of s minus 2 divided by s minus 2 whole square plus 3 square, who is going to be equal to inverse who is going to be equal to e to the power, according to this formula, e to the power instead of a we have 2, so 2t, then inverse Laplace transformation of f of s. So here f of s is nothing but this one, right? Its inverse Laplace transformation is 3t, cos 3t. So that's why we're gonna have e to the power 2t cos 3t, right? So let me clean this, just wait. Just wait. So hope you have understood this. So this is gonna be e to the power 2t, or you can do one more step, that is, yes, just okay, inverse Laplace transformation of s by s square plus 3 square. You can write one more step, then plus 4 by 3 Laplace transformation, inverse Laplace transformation of this is gonna be equal to e to the power. We're gonna use the same logic. This is f of s minus 2, right? So that's gonna be also equal to e to the power 2t, e to the power 2t inverse Laplace transformation of 3 by s square plus 3 square, right? So this is now in this form. This is e to the power at inverse Laplace transformation. This is f of s, right? Now in this form. So hope you have understood this, right? So therefore an inverse Laplace transformation, here this f of s is nothing but this one, okay, s plus 2 divided by s square minus 4s plus 30, and e to the power minus 2t, sorry, not minus 2t, sorry, 2t, and inverse Laplace transformation of this is nothing but cos 3t, then plus 4 by 3 e to the power minus 2t, and inverse Laplace transformation of this is sin 3t, right? Because we know inverse Laplace transformation of s by s square plus a square is cos 80, and if you have a here, then it's going to be sin 80, right? So hope you have understood this. So this is the answer. That's how we can use the partial fraction method to solve such kind of problem to obtain the inverse Laplace transformation. So let's take one more question. So now let us obtain the Laplace transformation of this. So here it is, capital F of s is 3s plus 1 by s minus 1 into s square plus 1. So here you see, let us consider this is a by s minus 1. Let us use I'm going to use the partial fraction method, okay? So So now b into, as this part is quadratic, so here we have to consider b as plus c, right? Then s square plus 1. Okay, now you see, let us find the value of b, a, b and c. Okay, so how to find that? Here you see, if you multiply both sides by the denominator, then what you're gonna have? Then you're gonna have 3s plus 1 and a into s square plus 1, then plus bs into s minus 1 plus c into s minus 1. Okay, now comparing the coefficients. So here from you, so if you simplify this, so then what you're gonna have? A s square plus a, then bs square minus bs plus cs minus c. That's what you're gonna have. Now this is s square, this is s square, so from here we're gonna have a plus b s square, then plus this from these two we can take s common. On taking s common, we're gonna have minus b plus c into s, then next we have a and minus c plus a minus c. Okay, so here you see, on the left hand side there is no s square term, so we can say that a plus b is equal to 0, comparing the coefficients. Then minus b plus c is 3. Here minus b plus c is equal to 3, then a minus c is 1, constant, equal to 1. So now let's so here it should be b plus c, it should be b plus c. So now what we're going to do here, first let us add these two, then what we're going to have, minus b plus b will be cancelled, then a plus c, that's going to be equal to 0 plus 3, that's 3. Now let us add these two, then what you're going to have, then you're going to have a plus c plus a minus c is equal to 3 plus 0, so minus c plus c gone, so you're going to have twice a is equal to 3, right? Sorry, this constant term was 1, right? This is supposed to be 1, right? If that is the case, then it should be 4. That should be 4. This is twice a. So then a is equal to 4 divided by 2, that is 2, right? So if you put the value of a here, then you're going to have 2 plus c is equal to 3, that is c is equal to 3 minus 2, that's equal to 1. So we have got a is equal to 2, c is equal to 1. Now let's put the value of c here, then you're going to have b minus b plus c is 1, so equal to 3. So you're going to have b is equal to minus 2, right, if you solve this. So now you see what we have done, we have solved these three equations. Okay, solving these three equations, what we have got? We have got a is equal to 2, b is equal to minus 2, c is equal to 1, right? So therefore we can write f of s, which is equal to this. So if you put the value of a and b here, a, b and c, then what we're going to have? Then 3s plus 1 by s minus 1 into s square plus 1, that's going to be equal to 2 by s minus 1 plus minus 2s plus 1 by s square plus 1. That's what we're gonna have. Right, now let me copy this. Let me go to the next slide. Right, so this is what we have got. So inverse Laplace transformation of f of s. So inverse Laplace transformation of 2 by s minus 1, then plus inverse Laplace transformation of minus 2s plus 1 by s square plus 1. That's what we're gonna have. So now we can write this way: inverse 2 into inverse Laplace transformation of 1 by s minus 1. Right, so now you see inverse Laplace transformation of 1 by s is equal to 1, right? But we have now inverse Laplace transformation of 1 by s minus 1. That means this is f of s, you can say, and then this is f of s minus 1. Okay, if you take its inverse Laplace transformation, then you have you're gonna have e to the power 1 into t, then inverse Laplace transformation of f of s. Right, so what is the f of s here? In this case, 1 by s. So, and its inverse Laplace transformation is 1. So this is going to be equal to 1. So that is e to the power t. That's what we're going to have. Right. So here we have 2 into e to the power t. And again, here you see this term can be written as inverse Laplace transformation of minus 2s by s square plus 1, then plus inverse Laplace transformation of 1 by s square plus 1. Right, so this minus 2 can be taken out, so then we're going to have minus 2 inverse Laplace transformation of s by s square plus 1, s square plus 1 can be considered as 1 square, then plus Laplace transformation of 1 by s square plus 1 square. That's what we will have. Right, so now you see, let me bring it down. Okay, now what we get here, minus 2 inverse Laplace transformation of this is cos 2, cos t. That should be cos t, and let me cut it. And inverse Laplace transformation of this is simply sin t. So this should be our answer, right? So this is our answer. So this is the inverse Laplace transformation of 3s plus 1 by s minus 1 into s square plus 1. Right, so hope you have understood this. So thank you for watching. See you in the next video. Okay.